Hello, 108 class. Mr. McHugh back here with you on section 9.4. We are going to wrap up here on page 5 for this section, and we're going to do example number 6. Now I have to caution you, this is from the old edition, which is kind of cool in a way. You can watch me do this example of modeling real data. This happens to be dealing with public trading companies during the 90s and filing for bankruptcy. Okay, so I'm going to talk through here, and you get extra practice if you go to page 526. You will see the version in your book, example. This is going to be the consumer price index. This is a problem that deals with a basket of goods, and the problems are very similar. It's just a matter of what quadratic equation are you using, okay? But when you follow me here with this example in our class notes, it'll be the same way. So you'll have two opportunities to watch these. So okay, so here we go. So back in the previous edition when I wrote this up here, I love quadratic equations and modeling. Remember, it's a parabola. They go like this or they go like this, okay? And back in the 90s, a lot of public trading companies were filing for bankruptcy, and so statisticians, mathematicians got together and they figured out that f of x, meaning the number of failures, was equal to the year, which is going to be x, and it was this crazy 3.37 x squared minus 28.6x plus 133. X is the number of years, and x was started in the year 1990 when x was equal to 0. So if you go 9 years later, x would be 9, which represented 1999. Makes me think of the old Prince song. It's gonna party like it's 1999. I say that to my wife. She says, get out of the 90s. It's 2012. So, okay, so here's my corny humor for the day. So how do we do these problems? They say, how many bankruptcies were there for 1995? These are the easy ones to do, because all you do is you take the given quadratic equation or function, and instead of putting x, you put 5 in and you substitute it, and then now you're in plug and chug mode. Now I just want to point out something real quick. What if I asked you to find out how many bankruptcies there were when x equals 0 for 1990? How quickly could you come up with that answer? If you put 0 in here, what do you get? 0. Put a 0 in here, what do you get? 0. At 0 plus 0 plus 133, there was 133 bankruptcies back in 1990. Okay, just showing you how quickly. So it starts off with 133. So, and I want you to see trend analysis here. So 1995, we're going to represent with a 5. We plug it in. 5 squared is 25, multiplied by 3.37. You can do the arithmetic here. 84.25. Multiply these two, you get 143 plus 133. Add, subtract the numbers, and you find out in 1995 there was 74.25 failures. What's that compared to back in 1990? It was less. Okay, so it was up high, and then it's coming down low. And then what they're going to ask us for, they're going to say what year. This is part B now. So now you're going to go the other direction, meaning this: given that there were 150 failures, you're given that part, what year, meaning what was the x, what year did that occur? Okay, now these ones are a little tougher, but let's start them out. You put the 150 in. This is again the quadratic equation given to you, the model of it, 3.37 x squared. And I look at this and I don't see anything that divides out evenly, so I'm going to move 150 over to the other side, subtract 150, get that 0, because remember, standard form for the quadratic equation is always 0 equals. Set all the terms over to one side equal to 0. Okay, now that you've done that, you now have your A coefficient, your B, and your C. And now you've got some decimal numbers here. You definitely got to use the calculator on this. It'd be crazy if you don't, I think. I still like to write my little box, put the values for A, B, C. Oh, what am I going to use to solve this? Oh yeah, the quadratic formula. Now, you know you're allowed to write that down on a reference sheet, but practice writing it down. I would expect to see this in your notebook. You write this every time. The more you do it, the more you'll get it burned in your head, the more you'll have it memorized, because you're going to need that for 143. Okay, so now we plug in accurately. Look the B's, look at the A, look at the C, look at the parentheses. Okay, I can actually go back and cover my work. If you make a mistake here in this arithmetic mode, you got to go back between what you wrote and your calculator. You got to figure it out. So show some work. Don't just one button push it all into the calculator and then you get the wrong answer. Okay, negative times a negative is a positive. Now, if you, well, in the old book I would told you to look at the example. When you follow the example 6 in the book, you will be able to see them work out those details, so you'll be able to see it. So anyway, back to the problem. Underneath the radical, you do that first. Take negative 28.6, square it, multiply these three numbers. It's a positive side, and you add them up. Divide by 2 times 3.37. Sorry, I don't have the nitty-gritty detail work here. When you work it all out, you should get 9 or negative 0.56. You're going to circle the positive 9 because we don't have negative years, and that means it was 1999 when that happened. So again, look at this. You had 133, 74 failures. Then in 1999 you had 100. Oops, make that a little higher. 150. And so if we had time and I had that class project, I could give each student a number from 0 to 10, 0 to 20, and we could plot all these data out, but we would see this parabola being formed. Okay, that's a big thing I just want you to see here. Oops, sorry, that's kind of crazy looking. Okay, I think that's it for now. Again, check the examples in the book. You're on page 526 to follow it again. It's a matter of neatness and precision and accuracy. That is a great skill to learn here in math. Don't be sloppy with these works, okay? This is where in my class I give a big spiel about being a system engineer, the person or the engineers who are neat and accurate, who follow the details, don't make mistakes with negative signs, are the ones that get the promotions because they get the job done. And that's what I'm trying to encourage you guys. So think of this as an opportunity for you to show that work. You could verify these numbers. I tell students anytime a project ever goes off, there's numbers calculated. If you work for Micron and you were going to come up with a new memory chip here, I promise you they spend hours of reviews to make sure that every detail is done correctly before they start going to manufacturing, because if anybody's off a thousandth of an inch building those things, they won't work. Okay, so enough of my spill here, so keep working hard, class. Mr. McHugh going to say adios to section 9.4. We are done. When I see you again, we'll start 9.5. Okay, take care. Bye.